Now let's take a look on NP chart. NP stands for non-conformity proportion or non-conformity products or services whenever you have in any NC part. N NP chart can be very useful. An NP chart comes from the family called attribute data. Attribute or discrete data, the data which you can count or classify. Since the very nature of attribute data is to classify, right? Hence, in the family of defective, you can use P chart that we saw before. Now we are going to take P stands for proportion. Now we are going to take a look on NP chart. So NP chart required just like anything P chart, it requires only defective as well as how much sample been inspected. Using these two columns, we can easily calculate the rest of other columns. So all the one which are there in the black font are the calculated one. So let's discuss about, now we talked about uh, the the data type. For example, it comes in attribute data and all that we talked about. Now let's take a look on what's the formula. Formula for the NP chart is that, for example, in order to calculate, let's start with the P bar, for example, NP bar. So NP bar, if you wanted to find out the NP bar is nothing but same like what you usually do for the P bar. What do you have to do with the P bar? So, for example, P bar where you will take the sum of defective divided by how much sum of inspected, right? So, this is what you will do it. And now in one more thing, what you will do in this NP chart is that converting from P bar, that is proportion to this one, NP bar, of course, it is there in the percentage. So summation of again, so what is the one? So defective part. And instead of inspection, what you will do, you will go with N number, right? For example, here we have 25 is the sample. That 25 you will get. With that NP bar, as I said, that bar is nothing but average. So you can easily find it out. So this is the difference between P bar and NP bar. Remember, P bar goes with the defective and versus in inspection quantity, and NP bar effective versus the number. It doesn't calculate on the one, although it's in the subsequently for LCL, we're going to use both of these components. Let's take a look. So what is the formula is that, let me take new sheet. So as I said that NP bar and P bar. P bar we have learned it's summation of defect divided by summation of inspection quantity, right? With that, we can easily find out. P bar, summation of defective. So this is also defective, not defect, divided by, and you need to put N, how much samples or how much subgroups you have, right? So this is the way we can easily calculate. Now we are talking about the LCL and UCL. So L, lower control limit, upper control limit. Lower control limit is that formula is very, very simple. NP bar, that is the value what you are going to get it, minus, since we are talking about lower, so we need to apply minus. And then you have 3 into square root of, you have two component, NP bar, and then 1 minus of P bar, right? 1 minus P, what will happen? For example, you have now you will get like a yield percentage, right? For example, your percentage of defective is 10 and 1 minus P is 90. That's what easily you can easily identify the formula. Now with that, we can easily identify UCL. That is, all we need to do is that you need to make it plus. This minus will become plus. So this and NP bar, once again, square root of NP bar, 1 minus P bar as such. So this is the formula. Let's apply that formula and get this value, right? As I mentioned that let's do it from the scratch. We do need two components. One, we need inspected quantity. and do need the defective number of defective quantity. And if you wanted to use, let's say you wanted to use something called month or date or whatever, maybe you can use it. Maybe I'll make it very simple for you. What I will do, I'll make only Feb to December, only 12 data set I have. And then let's say the quantity of inspected quantity is 500 example. And I'm just giving across the board. Let me keep it as a fixed sample. And then defective. So defective, let me keep that each time the defective rate is going to be 10 between 20 example. Or yeah, so now we got this one. For example, the month of Jan, we got 20. This is normally what you will say. This is what you will do it in the bar chart, right? So bar chart doesn't give you a picture that how much samples, how much errors are happening and all that. It gives that idea that how much error is happening, but what's the lower control and upper control? That's what we are using control chart, right? So let's find out one by one. So with these three things, this is your input, and we can make it to only this is okay. And then with that we can put like p bar. I have this heading, so I can copy paste this one. Okay, now with that we can easily identify this. So how we can do, for example, p bar. P bar, as you know, that formula as I mentioned, sum of defective divided by sum of inspected. Right. Now the whole formula I'm going to repeat again because I need to add that up. So I will give you a 4. Okay, okay. Okay, I applied a 4. So now, for example, in this case, January, we had 2.6 percentage defective, and it goes on, right? I mean, this is an average, right? We are not talking about individual percentage, but we are not talking about individual percentage. We are talking about overall. Well, this is, we got the center line. And then NP, how it goes is it requires N, right? So N we already know, but I will invoke the formula. So let's say minus 1. So 12-month data we have. So because 1 is for heading, so 12 month. With that, we can easily identify that formula, sum of defective divided by En. And once again, this formula is going to be absolute reference, so I will give a 4. Okay, now this has been done. So 13 NP bar is 13. And so what I'm doing it, I'm just also creating this also as well, so that I can easily copy paste this value. Now this is done. Okay. And the next step, I don't need this much decimal, so I will keep it only 2 decimal. That's fine. Okay. So now that is done. So the other one is that LUCL. So now we are talking about UCL, right? So defective and plus 3 into square root of and that is NP. Sorry, need to use NP. So wait, let's do it. NP. This is NP plus 3 in square root of, and in the square root of what we are doing it, again we are doing it NP minus, this is important step, 1 minus P bar. Okay, now we are done, and then close this bracket up, right? And what we can do, we can go back, check the formula again. So formula is pretty much same, 3 into square root, and 2 times we are doing it with the NP, and 1 is P bar. Exactly 2 times with this NP bar, and D is that P bar. So this value is going to be dynamic. So what I'm doing it, F4 I'm giving it. Okay, I'm just creating this. So the same formula, what I will do, I will just apply minus here. Okay, let's do it. So minus. This is now you notice that something important. Now we got 3.8. That means we are gonna leave it. If at all, if we get any minus value, then you need to assume that as zero. For example, here in this case, if you look at it, here we have got zero value, right? So now, for example, let me do it this step for you. If let's forget about this. So NP bar plus this is minus 3 times square root of again this one 1 minus p bar, right? Now this is now how much value you are getting it, you are getting it minus. So the defective will never be minus. So what we can apply is that we can apply if condition here. If this value is found to be minus value, like maybe minus 0 example, or it could be any number, just convert back or to convert back to 0. Assume that as 0, right? So since this value has minus, right? The original value, if you see here, minus value. So I'm just converting back. So now what I'm doing it, I'm this entire formula, I'm giving it a 4. And then now it has become this one. So now you got that 0 also as well. Exactly. But here in this case, in our example, the value is not 0. So therefore, we will keep it as it is. Right? And now this is done. Once it is done, what we need, this is the main component, defective, right? The like individual. And then we need NP, and then we need, so this one. So to draw that, to draw the control chart, we need individual defective, as of course, and then we do need the NP bar, and of course we do need the P bar, and then LCL, and then UCL we need. Right? There are two ways, right? Here, I'll every time it will keep it will be changing, so I will just keep it as a value here now. Okay. So now what I'm doing it, I wanted to figure out using the control chart. I wanted to figure out how many are outlier and all that, right? So this is what I wanted to figure out, right? And so what I will do, I will just keep, instead of this name, I'll keep this name example, right? So, okay, I wanted to add the same data. I wanted to add this subgroup, right? All you can do is that you can just simply click on edit, this one, and then add this data, and I will call it as maybe LCL example. The LCL has this data example, enter it. So the LCL is ready now, right? Similarly, we wanted to find out UCL, right? Example, UCL you can give here, and then the UCL value you can give it here, and then UCL is also calculated. That means well within the limit, right? And then one more line we need, that is called P bar. So what we can do, we can just apply NP, and we'll just keep it like short, NP bar. I will manually type it, and then you can apply this as such. So this is like a middle line for us. Middle line is also done. So now symbolically, so anything upper is a more rejection, right? So we don't want that. What I will do, I will just change it back this to other color. So what I will do, I will outline it to red example. And and then here I will use same like how many tab, MINITAB, many tab using it. Similarly, I will keep it this one, like blue, blue color. Blue color is done, and then let's keep that, the lower is better, right? And when it comes to rejection, lower is better. So I will use light green example. It's too much light. Okay, let's say I will use this one, right? And then what I will do, I will just invoke this formula. Invoke this value. So now the value is been there. Okay. And what I will do, I will just give control B. So the value is well visible and all that, right? And if I just add the entire data levels, it looks very clumsy, right? So what I will do, I will pick up this line and add only the data level for this. Remember, I wanted to reduce this also as well. I'll keep it only two decimal is fine. Sorry, not decreasing the decimal point to only two. This is done. And here also the last data point I will keep it. And this is done. So this should not be confusion. So I will just use down, down I will use it. So it will not be any confusion. Okay, NP bar is also done. The last one is that UCL. So here UCL is also done. Now what I will do, I will just, this color I will give it. Example, I'm just giving this color. And the same color I will give it here so that it is visible. Here also the same color. And here also the same color. I wanted to stand out this number. So what I will do, I will just increase a bit. This one increase a bit. This one increase a bit. This is one way to do it, right? So where we just added a simple chart and then we added all the control limits. This is one way. Another one is that if you want directly like this, what you can do, you can just do like this also, right? And I've selected only for one, and then you can start doing it this way also as well, right? So it has given, and then you can add that individual percentage, and this also we can do, but only missing part here is that the individual one, right? So what you can do, right click, add the defective one, right? So defective, let's go back and edit it. Value is going to be this value, right? We can do that. So any one value we can do that. So whichever works for you can make use of it. Now, very importantly, it shows that NP bar is equal to 15.5, and this is the value. And now by looking at the control chart, all will within the limit, right? And we wanted to determine whether the same value NP bar, so-called the mini tab, MINITAB, is giving the same value. So what I will do, for many tab, it requires only this. All these will auto calculated. Just going to many tab in here. I'll keep the value here, right? And then start. Then of course, this is control chart, and then attribute chart, and then you have NP chart. So NP chart now defective divided by the inspected quantity, right? Okay. So let's see. Let's compare that value. So 15.5 exactly the same, and 27.13 we are getting it 26.94. This could be because there is small difference will be there, and here 3.87, closer to 4, and here also we are getting it 4 assets, right? So this how we can easily get to know. For example, let's say if you want, instead of this, if you want month, you can stamp that month also as well, right? Say month you want, you can do that month also as well, right? So this how you can easily calculate this value. And now the formula one more time, let's recap that formula. I'll keep it here. This is a formula, and NP, we're getting the same, and this is NP. NP for us is E, right? Again, once again, 3 into square root of this value, and again you have done the square root of E, again 1 minus P bar. P bar is nothing but for us D, right? So P bar is nothing but individual percentage, right? So individual percentage defect divided by inspected quantity, right? That also we got it. And with that, and then let's try to apply, and so just to ensure that we are doing right thing. 26, actually it is same, right? So this how we can easily calculate and perform in Excel access. So more value if you add it, for example, automatically it will get added, or even if you change this value, the key is that defective, sorry, equal to defect, random between, let's say I'm just keeping it this. So every time when you change, automatically limits get calculated. You don't need to do anything. It's a one-time thing. You set it up, and you will get it easily, right? So I hope you find it useful. Please do like, share, them, subscribe my channel. You have wonderful day.